Projective Geometry, Volume 1, by Oswald Veblen and John Wesley Young.
Chapter 7, Coordinate Systems in 2- and 3-dimensional Forms. Section 72, Finite Spaces. Exercises. 1. Verify analytically that two sides of a complete quadrangle containing a diagonal point are harmonic with the other two diagonal points. 2. Show analytically that if two projective pencils of lines in a plane have a self-corresponding line, they are perspective. This is equivalent to assumption P. 3. Show that the lines whose equations are x1 plus lambda x2 equals 0, x2 plus mu x3 equals 0, and x3 plus nu x1 equals 0 are concurrent if lambda mu nu equals -1, and that they meet the opposite sides of the triangle of reference respectively in collinear points if lambda mu nu equals 1. 4. Find the equation of the lines joining C1, C2, C3 to the 4 points 1 plus or minus 1 plus or minus 1 and determine the cross ratios of the pencil. 5. Show that the throw of lines determined on C1, C2, C3 by the 4 points 1 plus or minus 1 plus or minus 1 is projective with equal to the throw of lines determined on B1, B2, B3 by the points A1 plus or minus A2 plus or minus A3 if the following relations hold. A1 plus A2 plus A3 equals 0. A1 C1 squared plus A2 C2 squared plus A3 C3 squared equals 0. A2 A3 B1 squared plus A1 A3 B2 squared plus A1 A2 B3 squared equals 0. And that the 6 cross ratios are negative A2 divided by A3, negative A3 divided by A1, negative A1 divided by A2, negative A3 divided by A2, negative A1 divided by A3, negative A2 divided by A1. C. A. Scott, Modern Analytic Geometry, page 50. 6. Write the equations of transformation for the 5 types of planar collineations described in section 40, chapter 4, choosing points of the triangle of reference as fixed points. 7. Generalize exercise 6 to space. 8. Show that the set of values of the parameter lambda of the pencil of lines m plus lambda n equals 0 is isomorphic with the scale determined in this pencil by the lines for which the fundamental lines are respectively the lines lambda equals 0, 1, infinity. 9. Show directly from the discussion of section 61 that the points whose nonhomogeneous coordinates x, y satisfy the equation y equal x are on the line joining the origin to the point 1, 1. 10. There is then established on this line a scale whose fundamental points are respectively the origin, the point 1, 1, and the point in which the line meets the line L infinity. The lines joining any point P in the plane to the points infinity sub y, infinity sub x meet the line y equals x in 2 points whose coordinates in the scale just determined are the nonhomogeneous coordinates of P, so that any point in the plane, not on L infinity, is represented by a pair of points on the line y equal x. Hence, show that, in general, the points x, y of any line in the plane determine on the line y equal x a projectivity with a double point on L infinity, and hence that the equation of any such line is of the form y equals ax plus b. What lines are exceptions to this proposition? 11. Discuss the modular plane geometry in which the modulus is p equal 3. And by properly labeling the points to show that it is abstractly identical with the system of quadruples exhibited as System 2 of page 6. 12. Show, in general, that the modular projective plane with modulus p contains p² + p + 1 points, and the same number of lines, and that there are p + 1 points, lines, on every line, point. 13. The diagonal points of a complete quadrangle in a modular plane projective geometry are collinear if and only if p is equal to 2. 14. Show that the points and lines of a modular plane all belong to the same net of rationality. Such a plane is then properly projective without the use of assumption p. 15. Show how to construct a modular 3 space. If the modulus is 2, show that its points may be labeled 0, 1, ... 14, in such a way that the planes are the sets of 7 obtained by cyclic permutation from the set 0, 1, 4, 6, 11, 12, 13, i.e. 1, 2, 5, 7, 12, 13, 14, etc., and that the lines are obtained from the lines 0, 1, 4, 0, 2, 3, 0, 5, 10 by cyclic permutations. For a study of this space, see G. M. Conwell, Annals of Mathematics, Volume 11, 1910, page 60. 16. Show that the 10 diagonal points of a complete 5-point n-space 0, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 1, 1 are given by the remaining sets of coordinates in which occur only the digits 0 and 1. 17. Show that the 10 diagonal points in exercise 16 determine in all 45 planes, in which each set of 25 contains 4 diagonal points, while each of the remaining 20 contain only 3 diagonal points. Through any diagonal point pass 16 of these planes. The diagonal lines, i.e. lines joining 2 diagonal points, are of 2 kinds. Through each of the diagonal lines of the first kind pass 5 diagonal planes. Through each line of the second kind pass 4 diagonal planes. 18. Show how the results of exercise 17 are modified in a modular space with modulus 2, with modulus 3. Show that in the modular space with modulus 5, the results of exercise 17 hold without modification. 19. Derive homogeneous and nonhomogeneous coordinate systems for a space of n dimensions, and establish the formulas for an n-dimensional projective collineation.
Projective Geometry, Volume 1. This book was written by Owald, Veblen, and John Wesley Young. It was published by Blaisdell Publishing Company, London, 1910, and is now in the public domain. It is read by Jim Renhold, with programming and illustration by Jim Renhold, 2019. Thank you for listening.